Rubinia and I'll be taking part in International Science and Social Science Competition 2020. So today I'll be presenting to you about my innovation product and you'll get to know more about my product and how it can actually benefit people in this society. So without wasting any time, come let's get started.
The title of my product is Implementation of Internet of Things IoT-based rainwater sensor system controlled through mobile application using Arduino. Before moving on to the core part of my project, I would like to tell you a little bit about myself. My name is Rubinia and I'm a student at INTI International University Nilai and currently pursuing my degree in computer science. My major is software engineering. First and foremost, I would like to thank INTI for always recognizing students' effort and giving me an opportunity to take part in this competition, and also not forgetting my lecturer, Dr. Maliti, for her never-ending guidance and support. So thank you to all of them. So why did I choose this project? It is because Internet of Things, most commonly known as IoT, is an evolving technology that has changed human perspective. Everyone is actually looking into how IoT can benefit people further. A simple example would be a smartwatch. Did you ever wonder how a smartwatch works? It is pretty simple. The watch is actually integrated with many sensors like heart rate sensor, which will read the heart rate of humans when we wear it, and an accelerometer sensor to detect human movement. This is where we are able to get the steps reading. Some watches are even beyond it where it can detect particular movements like jogging, exercising, and walking. So the whole idea works with a simple sensor integrated in the product, and it is able to capture data and process it as information for humans. Thus, we are able to monitor our health and fitness with a smartwatch. Moreover, IoT enables users to connect devices in a convenient way to either control or monitor the system depending on what has been developed. In my project, the user is able to monitor the rain sensor value and control the system with specified function which will be looking into it later on. This would be my discussion point. As everyone knows that Malaysia is a warm and friendly country, and that's mainly because Malaysia is located near the equator. Equator is commonly identified as Garisan Khatulistiwa in geography. Therefore, even Malaysia's climate is categorized as equatorial, which is being hot and humid throughout the year. Therefore, the rainfall that Malaysia experiences throughout the year, especially during the year end, worries Malaysians to leave their home and go on for a vacation, as their house will be in total darkness when it rains heavily. This is where people are actually reluctant to go for a holiday, since it's a rainy season, and some are probably even worried about their home. So here comes a solution where lights are on even when it's raining. The main objective of my project is listed as stated. IoT actually encourages machine-to-machine communication, where ingenious innovation allows physical devices to stay in touch with one another, leading to great efficiency and higher quality. Consequently, it can be developed in a way where user can monitor or control the system using mobile application through internet or Bluetooth connection. The output of the system is simplified to display as useful information in the mobile application where the user can keep track of the status of the system. Besides that, IoT device can actually give great impact to society in a meaningful way. For example, the system enables the user to turn on lights at home when it's raining and deactivate the alarm. For the methodology, I've decided to use both quantitative and qualitative measures. For quantitative, I use questionnaire. I use Google Form to design my questionnaire and distribute it to a large group of people. Through my analysis, I discovered quite a number of them are not aware of IoT and Arduino platforms as they might not have been exposed towards it, or even they are much more concerned in their own field where they don't have time for things. In short, they are not a multidisciplinary group of people where they only focus on fields and careers that evolve between them. For example, the people in business background are likely to look into business transformation process requirement needs rather than the information technology field. In fact, they might even think towards to implement any new technologies and trends of information technologies in their business environment as it is costly. For qualitative, I have successfully carried out the interview. During the interview section, I have discovered the people are not only interested in buying the system, but they also want to get to know more about the features and functions of the system. They've also mentioned that they want to try the system in hand first before recommending it to others. For the implementation part, I have used an Arduino Uno microcontroller board, which is an open source electronic platform based on easy to use hardware and software. Arduino boards are actually able to read inputs, like in my case, I'm using the rainwater sensor, and turn it into an output like turning on an LED automatically. Besides that, I have chosen to use Bluetooth module HC06, which adds the wireless functionality to my system. This module actually enables Arduino to communicate with any device with Bluetooth functionalities like a phone or laptop. In my system, I have chosen to develop my own mobile application using MIT App Inventor platform. Therefore, the phone is connected to the Bluetooth module, which eventually receives output as programmed in the Arduino board. MIT App Inventor is an online platform designed to teach computational thinking concepts through development of mobile application. This is my initial system without a Bluetooth module, but after completing my methodology part, I realized that a wireless system would be promising. Therefore, I have improvised the system by integrating the Bluetooth module. There are some important points that user has to be aware of before connecting their device to the system. Firstly, they have power on the Arduino board. And secondly, make sure that the Bluetooth is connected to the right device, which is HC06. This is the module that has been using in my system. And make sure they turn on the system by clicking on the on button. This is because mainly I have designed the system in a way that they have to ensure that the Bluetooth connection is connected, where they can look at the link status, it is stating connected, and they have to make sure they on the system in order for it to operate. These are the functions that I have provided with the user. For example, they can on the LED or off the LED depending on the situation, and of course, when it's raining heavily, the buzzer is activated automatically, so the user can choose to off the buzzer. I feel there is no need for the user to activate the buzzer, therefore the on buzzer button is not provided. And of course, they can choose to off the system whenever they don't want it to operate. And disconnect. Disconnect mainly means they are not able to get the reading of the sensor. This is my system limitation and future improvement part. System limitation is that functionality of the system is highly dependable on the environment condition. For example, when it's not raining, the system is going to be in the operation mode, but it's not going to give you any output. When sensors damage due to certain circumstances which reduce the performance of the system, or we may not even get output of the system as intended because the sensors are damaged and unable to get the input of the system. Future improvement would be develop a user-friendly interface for the mobile application, as my mobile interface does not focus on user interface design. It focuses more on the functionality. That's why you can see they are having a lot of button instead of having a multimedia elements. Finally, the system can actually work with multiple sensors. For example, we can integrate the system with soil moisture and humidity sensor, which will be very helpful in irrigation field. So that's the end of my presentation. Come, let's move on to the system demonstration.
So this is the setup for my system demonstration. Let's assume that John's house is located at the left hand side. So I'm going to quickly power on the Arduino board using a power bank, but alternatively you can use other sources as well. And now let's make the connection to the system using this mobile application that I have created. First of all, we have to make sure that the Bluetooth is on, and that's mainly because HC06 module which I'm using in my system can only accept a connection from another device, unlike HC05 module which can initiate a connection to another device. And that's the reason why we should on the Bluetooth first before we open the application. And you can see this, you have to click on the Bluetooth connection and make sure you have to click on HC06. And as you can see, the link status is connected, and as mentioned earlier, we have to on the system. Now you can see the sensor value. The initial reading is supposed to be 1023, and that's mainly because the rain sensor module is connected to 5 voltage pin in Arduino, and therefore this 5 voltage pin gives us an initial reading of 1023. So during rainy season, the rainwater increases wetness on the rain sensor board, which decreases the resistance offered. As the resistance decreases gradually, the output voltage starts to decrease as well, where the initial reading will eventually decrease accordingly. So now let's assume that it's raining. As you can see, there is a rainwater on the module. The reading actually decreases eventually, and you can see there is some sort of like hint given, like raining, and the light is turned on, and you can see the LED is actually turned on over here. Now I have programmed the system in a way that the sensor value reading has to be lesser than or equal to 500, then the buzzer will be activated. So as you can see, and we can simply click on off button to deactivate the buzzer. Alternatively, I can actually on the LED and also off when it's not raining, since I have provided the function to the user. For example, you can see currently the LED is not activated. So let me just click on LED button, and you can see the LED is actually blinking. And let me just off. Now it's off. So that's all for my system demonstration. Thank you.